Hi, my name is Autumn McSwain, and this is my Lab 1 constant velocity report. So, the purpose of this lab is to compare the actual and theoretical position of an object traveling at a constant velocity. The objective is to utilize this lab to demonstrate the principles of Newton's second law in real life and to give first-year physics students such as I a hands-on experience with the principles of physics themselves. So, Newton's second law, or the momentum principle, states that the acceleration of an object is directly proportional to the net force acting on it. This gives you the formula force equals mass times acceleration. This formula can also be derived to find the velocity formula, which is final velocity equals initial velocity plus F net divided by mass times delta t. So, the procedure for this lab was to record a video of an object rolling in a straight line at the same speed without changing directions. You then had to import this video into Tracker and track the object's position frame by frame using the auto tracker function. You also need to make sure that the calibration stick was set, otherwise your data would not be consistent and it would be impossible to use that data. Once that was done, using the data, you could then find the velocity of the object from Tracker and use that to create a model of the object's predicted position in GlowScript. Once you had this done, you would then have two graphs of your actual and theoretical data that you could use to compare over time the data over time. So for my tracker data, I imported my video and the total time was 3.5 seconds with the initial position of 0.177. You only are using the x-axis because it should only be moving along the x-axis and we are not worried about the y-axis. To find the initial velocity from this video, we were able to do position final minus position initial divided by time final minus time initial. When this was done, I did it over a 1 second interval and got 13 as my velocity. I then was able to put this into GlowScript, where the net force was equal to 0, delta t was set to 0.01, and mass was not utilized because it was negligible in this experiment. Initial velocity and position are plugged in to where the ball's velocity equals the vector 13, 0, 0, and ball position equals ball position plus ball velocity times delta t. Once this was done, both of my graphs were given, and they are shown here, with my actual data on the left and my theoretical on the right. My actual data tends to be more curved versus my theoretical data that is pretty much just linear. This shows that an external force did happen to the actual data that caused it to curve, whereas that was not found with the theoretical data. This means that there were error within the experiment itself, and some reasons for this could be friction and air resistance that affects the system. Friction could have caused the rolling force to be slowed down, which would cause it to slow down over time, which could account for why the graph curves at the top, whereas the theoretical is straight. Furthermore, there could also be a rounding issue that alters the precision of the experiment, because the more decimals you have, places you have, the more accurate it will be. However, keeping track of however many decimals is not possible, so mine was rounded down to 3 decimal points, as well as there was just error within tracker. This is because to use the auto tracker function, you basically have to set a box on what you are wanting to track, and as long as tracker registers within that box, it will count it, but that creates error as the data points are wild and different and not consistently in the same spot on the object itself. So for discussion, how would the results change if positive x and negative x were interchanged? This would just cause the slope of the graph to be negative. That would be all that really changed there. This lab also shows that the net force was not 0 because other forces such as friction and air resistance caused there to be a bigger force against the object. This is why the actual data, the ball is slowing down because friction is pushing against it, which is having a bigger effect on the rolling force, as well as there's probably a little bit of air resistance as well that is helping friction slow the object down. And that is my lab. Thank you.